Let's look at the last section in security fundamentals. This one is not to understand basically what the theory is, what the threats are, what some of the things to mitigate it. The question is, how do we do it? So we know the why. Now we got to know the what. What do I have to do? Well, some of the newer routers have something called Cisco Secure, where you probably already have a passwordy computer, a smartphone, and stuff. But the question is, how do I assist securing an entire system? How do I make a router secure? So here you've got auto space secure on some of the newer systems that allow you to handle most of this. So you can, with this, you can set up default usernames and passwords that are changed. You got to make sure access to the systems are, who can make modifications to the system are restricted to people that can only have authorization. And then make sure you can control any unnecessary services that you're going to. Now, when it comes to passwords, you want to make sure that you've got strong and long passwords. Some of the now with high-speed computer stuff, brute force guessing a password is relatively easy to do. So you're probably going to be pushed right now. I think they're saying minimum of 8 characters. But basically, the longer it is, the longer it takes people to break into it. You want to make sure that passwords are complex, uppercase, lowercase, numbers, symbols, spaces. Some systems allow you to do that, some don't, but the more complex it is, the harder it is to guess. You definitely want to avoid passwords that are repetitive, that are common dictionary words, have number-letter sequences that can be guessed, relatives, paths, things that people can generally find out about you. You want to make sure that those are taken care of. Maybe you want to misspell words or replace certain characters with numbers. Of course, you want to make sure you change your passwords often. And definitely do not write down your passwords and stick it on a sticky note it's under my keyboard. Nobody goes into my office. You leave your door open, somebody's out looking, they're looking at your keyboard and say, guess what? And down here you see definite examples, why it's strong, why it's weak, and then some examples of strong passwords. Combinations of the length is 1, and then 2, it's the combination of alphanumeric or alphanumeric symbols and spaces. So the longer and stronger you make a password and make it change, even though we all hate changing passwords, it's definitely something we need to do. So now the question is, strong passwords are only useful if you keep them secret. And of course, there's definitely, we've used some of these commands in previous labs, where once you type a password, you can encrypt all the passwords. There's a global command that changes all your passwords, encrypts all your passwords. And that's service password -encryption. And that will, all the passwords you take, all the ones you enter in here, all get encrypted. It may not be the strongest encryption, but everything is encrypted. Now, there are some other things you can do to say, how long do I want, I can set how long, what's the minimum length, how long will I block a person if they have so many invalid attempts. So those are types of things that you can do. I can do the exec timeout and says, hey, I'm going to reduce the setting to how long when you're at the console working on things, it automatically disconnect when you're inactive, so that if you walk away from your system, that nobody can just kind of walk in behind you and take over. And then one of the key things here is this transport input SSH. That's making sure that you're running secure shell and not telnet. So you want to make sure, because the default is running telnet, which is not a very secure. It sends all the data in a graphical format. It's a readable format. So you don't want to run that very well, very often. So when you're enabling secure shell, one of the labs you're going to go through is how to go ahead and enable it. And basically what you got to do is you got to create a unique device host name. Now, we've done host names, but you got to make sure it's a unique host name. And then what you're going to do is you're going to create a domain, an IP domain name, done with the IP domain name command. Then you're going to say, then I'm going to generate an encryption key for a secure shell. And to do that, you'll see the command crypto key generate RSA general keys, modulars, and the number of bits. And the number of bits gives you the size of the key that's going to use. It'll be between 360 and 2048. The more secure the key, the better it is. So the larger the bit values, the longer it takes to encrypt and de-encrypt. But for the most part, depends on what you're trying to protect. On normal, you want to do 1024. Would be a nice midpoint. You don't go too low, too high. Then what you want to do is create a local database entry. To create this local database name, you got to use username, and then you got to create a secret password, and then you're going to authenticate it against the local database, and then you're going to change what VTYs allow data in and out, whether I'm transporting what can come in and what can come out. Let's just get down to an example here. And you're seeing here where I changed the router, so I gave it a unique host name. I created a domain name. In this case, it's span.com. I create a key, and we use the default of 1020, not the default, but the nice number for that is 1024. And then once I've got all that key enabled, now I've got to say where I'm going to implement this information. So one, I'm going to set up a username. It's going to be username Bob. His secret passcode is Cisco. I'm going to go to the line. I'm going to say where I'm going to apply this password. So I'm going to use VTY 0 to 4. I'm going to have for local logins. And then I'm going to change the import transport, the data that's coming in and out. I'm going to change it to secure shell versus telnet. So it may seem like a lot, but basically you make sure the host is unique. You make sure you generate a key that can be used for a secure shell, create a username and password, and then say where am I going to apply secure shell? Which ports am I going to apply secure shell to? So you'll have a lab that goes through that. And now, of course, one of the things we want to make sure that you do is, okay, you've changed from telnet to secure shell, but I also want to turn off any services that I am not using, any ports that I am not using. Here you can see the command that shows show IP ports all, which lists all the ports that are being used. So the other one is if I want to, I'm not sure I use this control plane host open ports command, but it basically allows me, it tells me which systems are up and running, and then turning off, in this case I'm turning off the HTTP server, and I'm making sure that telnet is used. So you're going to get a chance to play with configuring secure shells and passwords and SSH, setting it up in one of the packet tracer labs. And then I think you're going to get, you've got 2 labs to play with that stuff. So hopefully this helps, gives you an intro to security as far as networks are concerned. Have a nice day.